sunlight, is usually between 0.3 microns and 2 microns in terms of wavelengths, and glass is transparent to these kind of wavelengths, the solar wavelengths, and this comes inside the house or inside the car, and whatever surface is exposed absorbs these wavelengths and gets heated up, and this heat cannot escape out of the glass because glass does not let this radiation to go through. The type of thin films that we are working with are the ones that are dynamic, in the sense that you can change their optical properties. It's an extremely thin layer that is applied on the glass or any other substrate. At room temperature, nothing happens, and the moment it gets heated to certain temperature, what happens is that the optical properties change, okay, and the light or the sunlight starts getting reflected. But what we have achieved in our lab is two things. One is they are very efficient in terms of the change that they go through. When the temperature is normal, it lets 70 or 80% of the light to go through. That is at higher temperature, it rejects away almost all of that, so there is no light going through at all, or the heat going through at all. So this is what is the efficiency. And the other thing that we have achieved is that we have lowered the temperature to about 45 degrees Celsius, and we are working on improving this temperature, or bringing down this temperature even to around 25 degrees. That means the maximum temperature to which the car gets is only 25 degrees. There is another application for another kind of thin film that we are producing in the laboratory. If the satellites are covered with the kind of thin films that we are proposing, the moment the satellite comes, is exposed to the sun, because the intense radiation is heat radiation is hitting it. Now very soon the temperature gets to the transition temperature or the changing temperature of the satellite, and it starts rejecting the heat. And the moment it goes in the shade and the temperature falls below this transition temperature, again there is absorption, so it keeps the heat to itself. One of the main advantages of this is that it is not a bulky solution, because we are talking about very thin layers. Maintenant, on est en train de développer d'autres types de couches minces qui sont statiques, c'est-à-dire ça ne change pas la propriété optique. Ce sont des couches ou des filtres optiques qui bloquent certaines longueurs d'onde specific. Here we have an example of what is called a smart window. In normal state, it is transparent. That means it lets the light go through, and once it is charged up, it colors. And when it is completely charged or completely colored, it cuts 100% of the heat part of sunlight. When you work in the laboratory, you usually work on a small scale prototype, and then to take it to the industry, what is very important is to deposit the same type of film with the same recipe, if you will, on a bigger scale. The support of NBAF has been fantastic because we had already shown that the research that we have done in our laboratory has this potential, in various applications, and NBAF has supported us to take it to the next level, and that's the work that is going on. On sera très content si on peut créer certaines compagnies ici, soit à Moncton ou au Nouveau-Brunswick, avec l'aide de ces applications. Parce que maintenant, on est en train de travailler avec cette compagnie, Lambda Guard, qui est intéressée de s'installer ici à Moncton. Donc, si on peut compléter le projet des couches minces ou le filtre optique, à ce moment-là, la compagnie sera intéressée de s'installer ici à Moncton et de fabriquer les couches minces.